Now that we've identified the two major things in order to write an equation or function, we're going to go ahead and write that equation or function to represent this line of best fit. So again, we used two coordinate points that fell on the line of best fit to span the data. We used them to find our slope, which is -5/12. And then we found the y-intercept, or where our line of best fit crossed the y-axis, and that's at 35. So in order to write my equation or function, it needs to be in slope-intercept form. So what that means is, if I kind of write off to the left here, what you've learned in the past and what you should have learned in your 8th grade math curriculum is that slope-intercept form is always y equals mx plus b. M is always your slope, and b is always your y-intercept, or your starting point. If I ask you to write an equation, I'm going to expect that your equation starts out with y equals. If I ask you to write a function, I'm going to require you to start out your function with f of x. Again, they're the same thing, but it's just different in terms of how we write an equation versus a function. So in place of the m, I'm going to put my slope, which is -5/12. So I'm going to put -5/12 in place of the m variable. And then I'm going to put my b value, or 35, in place of that. So this will be plus 35. So the function that best models my line of best fit here is f of x equals -5/12 x plus 35. So on my graph, I'm going to go ahead and just draw an arrow from my line of best fit, and I'm going to write that function down. F of x equals -5/12 x plus 35. So what that means now is, because I have a function that best represents this line, I can start to predict at future ages when the average emails per day happen, or how many happen. So if I wanted to predict how many average emails per day somebody that is 80 years old gets, I can use my function to predict that, meaning instead of x, I can put 80 in for x, multiply it by -5/12, get that number, and add it to 35, and find the average emails per day that an 80-year-old could or possibly expect to get. So that's the first part of lesson 2.1a, is using scatter plots to make lines of best fit, and then being able to use your line of best fit to come up with a function to represent the situation overall. The next part then of lesson 2.1a is talking about linear patterns. So as we've done in our previous math talks and have had on our previous assessments, I have 3 figures here that have different numbers of tiles. And what we're going to be looking for is a linear pattern, and then we need to use that pattern to draw the next couple of figures. So with that being said, what I first want to say is, please recognize that right now, as a nice visual, I have the figures drawn out. However, instead of having the figures drawn out, what I could have done is I could have listed numerically how many tiles are in each of these figures. So instead of drawing the picture for you, I could have drawn, just written the number of how many tiles this is, how many tiles this is, and how many tiles this is. But having a visual is nice. So if I look at figure 1, when I count, I get 1, 2, 3, 4, 5, 6 different tiles. When I go to step 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to go from 6 to 10, I know I have to add 4. So let's check figure 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This should be 14, because Mrs. Shack forgot to draw in a tile. That's her bad. So make sure that you draw in this extra tile here, because Mrs. Shattuck forgot to do that when she, or before she made this video. So now when I count, I have a total of 14. So that means also from 10 to 14, I added a value of 4. So now what I can see or can clearly see is there's this pattern of adding 4, or what we call an arithmetic pattern, because you are adding a certain number every time. So if I'm adding 4 every time, that means I can predict what's happening in the future, and I can also go back and figure out what occurred before. So my first step, when it says draw figure 0, I can go ahead and do that and backtrack. Meaning, if I know figure 1 has a total of 6 tiles and my pattern is adding 4, to backtrack, I can do 6 minus 4 and determine that figure 0 should have a total of 2 tiles. So I'm going to draw in 2 total tiles and label that as figure 0. So just like we can backtrack to get previous figures, I can now also progress forward and find future figures. So for number 4, again, if I ended up with 14 tiles in figure 3, if I add 4, I must have to end up with a total of 18. So for figure 4, I'm going to draw 2 columns with 3 tiles in it. So 1, 2, 3, 1, 2, 3. And then I'm going to go ahead and draw 3 columns with 4 tiles in it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now if I count all of these up, I will get a total of 18 tiles, and this is figure number 4. So I could continue this pattern and keep drawing on forever. The next figures that come, or the next number of tiles that I should have in my sequence. But to help me generalize and make those connections a little bit quicker, so I'm not having to draw out every single step, I can go ahead and complete a table. So as you can see here, I have figure number in my X or independent variable row, and I have the number of tiles in my dependent or my Y variable row. So for figure number, I have figure 0, 1, 2, 3, and 4 recorded. And so when I look back up at my drawings, again, figure 0 has a total of 2 tiles. Figure 1 had a total of 6. Figure 2 had a total of 10. 3 was 14. And 4 we determined to be 18. So then with that being said, I'm going to grab a different color and just reiterate the pattern that I'm noticing that's happening. So for all the figure numbers, as I go from one number to the next, I'm noticing that I'm adding 1 each time for my pattern. For my number of tiles, as I go from one to the next, I notice that I'm adding the value of 4 each time. Again, this is what we call an arithmetic sequence because we are adding the same number every time. So now that I'm asked to describe the relationship, what that means is I need to say in words what's happening to the figure number and what's happening to the number of tiles. So this would be a statement such as the figure number increases, because I'm adding, so increases, as the figure number, I wrote increasing, so I'm going to use my lovely whiteout. As the figure number increases by +1, the number of tiles increases, again because I'm adding, by +4. So this is reiterating the fact that I'm understanding the patterns that I'm seeing, and I'm also reiterating what is happening to my Y, or my dependent variable, as my independent variable is increasing by 1 each time.